Have you ever gazed up at the night sky and wondered how our Earth came into existence among the sea of stars? It's a profound question that has intrigued both the curious minds and the scientific community for centuries. This insatiable curiosity, this relentless pursuit of understanding, is what drives us to delve into the origins of our home planet. In the infinite expanse of the universe, amidst countless celestial bodies, the Earth was born through a series of complex cosmic processes. We call this planetary formation, a concept that encompasses the intricate mechanisms and phenomena that have shaped not just the Earth, but every planet we know of. As we embark on this exploration, we'll traverse the vast reaches of space and time, delving into the mysteries of the cosmos. We'll journey back to an age when our planet was nothing more than a speck of dust in the cosmic ocean. So, buckle up and prepare for an astronomical journey back in time to the very beginning of our world. Imagine a time about 4.6 billion years ago when our solar system was nothing more than a cloud of cosmic dust and gas. Let's delve into this intriguing era where the story of our planet begins. This cosmic dust and gas swirling in the vastness of space is known as a nebula. This nebula, like a celestial soup, was full of elements that would eventually form the very building blocks of our planet. Now picture this nebula being acted upon by the invisible hands of gravity. Slowly but surely, gravity began to pull together these particles, creating a denser and hotter core. This core, brimming with energy, ignited to form our young sun. Around this nascent sun, a flat, rotating disk of gas and dust began to take shape. This is known as the protoplanetary disk. Within this disk, tiny particles started to collide and stick together, gradually growing in size. This process, called accretion, led to the formation of planetesimals, the precursors to actual planets. These planetesimals, through countless collisions and mergers, continued to grow, birthing the seeds of what we now know as the planets of our solar system. Among these was a special one, a planetesimal that would eventually mature into our home, the Earth. And thus, the stage was set for the birth of Earth. From the swirling chaos of the protoplanetary disk, a new actor emerged, our Earth. Amid the cosmic ballet of dust and gas, the process of accretion began. Tiny solid particles, or planetesimals, started to collide and stick together. This was not a slow dance. The pace quickened and the intensity grew as these planetesimals coalesced into larger bodies, known as protoplanets. Just imagine a celestial snowball fight, where each snowball is a mass of rock and metal, growing larger and larger with each successful strike. These protoplanets, including the one that would become our Earth, were not quiet, peaceful places. They were hotbeds of activity, heated by the energy of their constant collisions. This heat, combined with the immense pressure of their growing mass, led to a process called differentiation. Differentiation is a bit like baking a layered cake. The ingredients start mixed together, but as the cake bakes, they separate into distinct layers. In the case of Earth, the heaviest materials, such as iron and nickel, sank towards the center, forming the core. This core is the heart of our Earth, generating the magnetic field that shields us from solar radiation. The lighter materials, meanwhile, rose towards the surface, forming the mantle and eventually the crust. This is the stage where our Earth started to look a bit more familiar, with a solid surface and a molten core. Yet, even with its layers in place, Earth was not the planet we know today. It lacked an atmosphere, oceans, and life. It was a hot, barren, and inhospitable place, constantly bombarded by leftover planetesimals. This was the birth of our planet, a violent and chaotic process. But it was from this fiery crucible that the foundations for life were laid. The Earth was taking its shape, but it was far from the hospitable place we know today. Around 4 billion years ago, our young Earth experienced a period of intense bombardment. This period, known as the Late Heavy Bombardment, was a chaotic time in our planet's history. Picture an endless barrage of asteroids and comets, each one striking the Earth with such ferocity that it dramatically altered the landscape, creating and destroying in equal measure. Now imagine a celestial body about the size of Mars, hurtling through the vast expanse of space. This Mars-sized object, often referred to as Theia, was on a collision course with our young Earth. This collision, however, was not the end, but rather a new beginning. The impact was so colossal that a chunk of the Earth was ejected into space. This debris, not content with floating aimlessly through the cosmos, began to coalesce, forming a new celestial body in its own right. This brings us to the giant impact hypothesis. This theory proposes that our moon, that faithful nighttime companion, was born out of this violent collision. The debris from the impact eventually came together, creating a satellite that has been our planet's constant companion for billions of years. The moon's formation was a significant event in Earth's history, affecting the planet's rotation, tides, and even the conditions for life. With the moon in place, the Earth was now poised for the next step in its cosmic journey. From a fiery, chaotic mass to a vibrant, life-sustaining planet, Earth's journey is nothing short of spectacular. Born from a cloud of cosmic dust, our planet, over billions of years, transformed itself into a beacon of life in an otherwise seemingly desolate universe. This transformation was no simple process. It required the perfect alignment of cosmic events, a dance of elements in the vast expanse of space. The dust condensed, solidified, and slowly, piece by piece, formed a rocky sphere. As the pressure and heat rose, the planet's core started to churn, creating a protective magnetic field. Water, the elixir of life, came next, perhaps delivered by icy comets or formed from the gases in the atmosphere. Over time, this water gave birth to the first primitive life forms, which evolved into the diverse array of species we see today. Understanding Earth's formation helps us appreciate the delicate balance that allows life to thrive. It broadens our perspective in the field of planetary science, giving us a glimpse into the processes that might be at play on distant planets. And there you have it, the birth of our home, a spectacle of cosmic events, a testament to the wonders of the universe.